Hi everyone. Today we are going to do a comprehensive review about recent advances in machine learning for personalization and recommendation systems. I'm Penusha Herath and my colleague is Samita Herath, and we both are going to do this presentation for you. So first of all, to the introduction, we are going to see about the importance of recommendation systems in modern digital platforms, then how personalization increases user engagement and satisfactions. Then what are the challenges uh, to this process, like algorithmic bias, scalability, and data protection? How we are going to recover and those kind of things. Then finally, how machine learning has revolutionized recommendation systems after the year 2020 with advancements. So first of all, the role of machine learning in recommendation systems. We all know that machine learning doing a massive work to the recommendation system, such as first of all, they are going to process large amounts of data and they identify data patterns and they generate precise predictions. Uh, we can see key developments in these recommendation systems, such as graph neural networks, we known as GNNs, then transformer models, contrastive learning, knowledge graph integration, and the fairness aware algorithms. Graph neural networks in recommender systems. We know that GNNs, they simulate complex connections between users and items. Then they capture higher order interactions. After that, they learn that rich embeddings reflect to local and global structures. So the advantages of these GNNs are like they addresses false start problems, then they improve scalability, and they more likely to that more precise and personalized recommendations. So the limitations we can see, like they have less computational requirements. So transformer models for sequential recommendations, they adapted from natural language processing. Then they capture long range relationships and contextual information from these models. So advantages of these transform models, like they have a better performance with long term dependencies. Then they have large data volumes with efficient handling. Then they improved session based recommendations for these models. uh, we can see an example like BERT forec. This is a bidirectional encoding for more thorough user behavior understanding system. Then contrastive and self-supervised learning. They both are useful in scenarios with limited label data. The contrastive learning means they differentiates between similar and dissimilar data points. Then the self-supervised learning, they create supervisory signals from the data itself. Benefits of these both systems, like they have a model, the improved model generalization, then the adaptability is enhanced, then they have better handling of noisy or imperfect data. So the challenges we can see here, like they have higher training complexity and computational needs. So I invite my colleague Samita to continue this presentation with the other points. Samita, over to you.
Thank you, Penusha. I will continue the presentation. Knowledge graph-based recommender system enhance the accuracy and the interpretability of the recommendations by providing extensive contextual data about entities and relationships. They help solve the false start problems and improve the personalizations of recommendations. However, these systems face challenges related to scalability, data quality, and the need of dynamic updates. Moving to the next slides, session-based recommendations focus on delivering real-time contextual relevant suggestions during short-distance user sessions. These systems often utilize methods such as recurrent neural networks, long short-term memory networks, and transformers. Meanwhile, fairness-aware recommendations aim to ensure equitable treatment of users by addressing data and algorithmic biases through technical like balancing data representations against algorithms. In summary, our key finding includes the effectiveness of graph neural networks in improving accuracy by modeling complex relationships, the enhancements of sequential recommendations by transform models, and the robustness introduced by contrastive and self-supervised learning. Knowledge graphs offer deeper contextual information, while session-based approaches adaptively handle dynamic user behavior. However, challenges remain, particularly regarding the computational complexity of graph neural networks and transformers, data quality of knowledge graphs, and the trade-off between the accuracy and the fairness. Looking ahead, future research should focus on scalability of graph neural networks and the transform models, advancing self-supervised learning techniques, and optimizing the interpretations of knowledge graphs. Additionally, developing fairness aware systems that balance accuracy with the equity and enhancing the explainability of AI driven recommendation will be crucial. In conclusion, machine learning has dramatically transformed recommendation systems, leading to improvements in accuracy, efficiency, and fairness. However, challenges in personalization, scalability, and the equity persist. The future of recommendation systems lies in serving use fairly and effectively across diverse contexts. Finally, these are the references we use for the presentation. Thank you very much.